In this video, I will be discussing the effect that the insertion of one base pair has on mRNA codons, and thus the represented amino acid sequence. Insertion or deletion of a base pair can result in a mutant protein due to a point nonsense mutation. We'll start by looking at the wild type or normal protein sequence at the top, and the mutant protein sequence at the bottom. The normal sequence given is methionine, tryptophan, phenylalanine, threonine, lysine, glycine, and continued. The mutant sequence given is methionine, tryptophan, isoleucine, histidine, and stopped. When we place the two proteins next to each other, you can see how the mutant sequence is much shorter than the wild type. This is due to a premature stop codon in the mutant sequence, which we will discuss shortly. If we begin to compare the amino acids within the two sequences, you can see that both sequences have the same first two amino acids, methionine and tryptophan. However, when you get to the third amino acid, this is where they begin to differ from each other. The third amino acid for normal versus mutant sequences are phenylalanine versus isoleucine, the fourth, threonine versus histidine, and the fifth, lysine versus stop. Now we are going to convert these amino acids and write down every possible mRNA codon. Methionine only has one mRNA codon, AUG. U is used because this is mRNA, and it is the start codon. Next, tryptophan also only has one mRNA codon, UGG. As we continue, phenylalanine has two codons, UUC and UUU, and isoleucine has three, AUU, AUC, and AUA. For the sake of time, I have written out all mRNA codons for the rest of the sequences, including the stop codon. As I go back in with highlighter, we are going to compare the codons to find where the base pair insertion or deletion occurs. So far, they are all the same. Oh, wait a minute, why is there an A here? This is what causes a frame shift. Then we must figure out which codon is being represented for the sequences. Since the histidine codon begins with a C, we know that phenylalanine codon has to be UUC. Then all stop codons start with U, so we know that threonine codon must be the ACU one. As for lysine and glycine, we do not have to specify a specific codon and can put AA blank and GG blank. So if we write out the mRNA codons, we get 5' AUG, UGG, UUC, ACU, AA blank, GG blank, 3' for the normal sequence, and 5' AGU, UGG, AUU, CAC, UAA, 3' for the mutant. The insertion of the base pair causes a frame shift mutation. As we know, reading frames occur in threes, so the addition will push one base pair over in each reading frame. Due to this, the codon UAA is created prematurely and causes the translation to end and not account for lysine or glycine. This is why a non-functional protein was created. Here are my sources.